Welcome to Graphing and Simultaneous Equations lesson number 7, solving simultaneous equations graphically. Consider we have the situation as stated here. So we've got two sets of equations and both equations have different unknowns in them. So there's an a and a b in the top one and an a and a b in this equation too. And what we want to know is what are the values of a and b. So what we're going to look at today in this lesson is how we can solve those values of a and b here. So the learning objectives for today is we want to be able to identify the point of an intersection of two lines, and using that identification, what we want to do is recognize that the point of intersection is the solution to two simultaneous equations. So going back, if we graph these 2 points or these two equations here, the point at which the lines that these equations represent, the point at which those two lines intersect will be the solution to A and B. Now, not running ahead of ourselves, let's give ourselves a quick reminder of what we had been looking at in the previous lessons. So consider the relationships of a line. So what we found is that there are two situations where this method is viable. So recall, or actually there are three situations. So recall, what we're looking for is the point of intersection of two lines, and that is going to be the solution to these simultaneous equations. So what we need to identify is which relationships have an intersection. And the first one is if there's an arbitrary intersection, they're going to cross at this point here. For collinear, it's going to be all of these points. So there's going to be more than one solution there. And finally, if we have perpendicular lines, notice that there is a point of intersection right here. But the odd one out is the parallel lines. So notice with parallel lines, by definition, they don't intersect at all. So if we have a set of equations and they yield parallel lines, then there's simply going to be no solutions there. So going downwards, what we're trying to do is solving via graphing and inspection. So if we graph two particular lines, so say this red line here, if we said this red line was equal to something of the likes, let's get rid of that, something of the likes y equals 3, we'll say negative 3x plus 2, and if this blue line was equal to, say, y, let's reduce the width of that, y equals negative 0.5 plus negative 1. If we graphed these two, now these, I should mention, these equations here don't represent these lines here, but suppose if they did, the point at which they intersect, so this point here, would yield the x and the y values for these two equations. Now let's go down to something a little more concrete. So we'll jump into an example. And we'll say we've got two equations. We have two equations. So equation 1 is y equals negative 0.5x minus 1 and y equals 2x plus 4. So what we want to do is we want to know what is the value of y and then what is the value of x. And remember, we're going to do this by graphing them. So looking at these equations, I'm going to graph it. So in the first one, we've got an m of negative 0.5 and we've got a c of negative 1. So to graph it, I'm going to say negative 1 is roughly here, and m, so m of, we'll say, number 1, c equals negative 1, so the y-intercept's negative 1, and m equals negative 0.5. And we could rewrite that as negative 1 over 2. So we've got a rise of 1 and a run of 2, or a rise of negative 1 and a run of 2. So going to this point here, let me get my red pen, we're going to go down a value of 1, then we're going to go across a value of 2. So our second point is going to be here. Now if I get my ruler, whoops, where's my ruler? Here we go. So if I get my ruler and I draw it through this point here, moving up this point right here, there we go, and we have a weight of nice thick weight. There we go. So that's equation 1. Now equation 2, which I will do in orange, we will have y equals 2x plus 4, and in this case the c is going to be 4 and the m is going to be 2. Therefore the gradient is 2 over 1. So graphing this, looking for 4 on the y-axis, we are here. And then using the rise over the run, we're going to go up 2 and then across 1. So up 2 here and then across 1. So here. So it's this point and this point. So if I go get another line to draw, there we go. So what we find is that the point at which these two lines intersect, that is going to be the value that we get, or the value or the solution to this equation. Now my lines aren't entirely accurate, but if your lines were accurate, what you would find is that the solution to this question, or the solution to these two lines, is this point here. And that point right there, that is equal to x of 0, sorry, not an x of 0, an x of negative 2 and a y value of 0. Thus the solution, so x and y for equations 1 and 2 as specified here, is negative 2 and 0. Alright, so that's example 1. Let's go down to another example. So consider we've got equations y equals negative 0.4x plus 1 and y equals negative 3x plus 2. Using the gradient and the y-intercept once more, I'm going to graph the lines. So finding 1 is here, and then I'm going to do a rise over the runs. So for equation 1, say c equals plus 1 and m equals negative 0.4, and that's equal to negative 4 over 10. So what we can see is we've got a rise of 4, or negative rise, so downwards, going down 4, then across 10. So let's go, we'll count the squares this time. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the way down there. And then we're going to go across oh no, we should go down 4. 1, 2, 3, 4. So here, sorry. Then we've got to go across 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be our second point here. Now drawing the line. As such. Try and be as accurate as I can. Done. So that's equation 1. Now looking at equation 2, we've got a C value of positive 2, and we've got an M of negative 3, or that can be written as negative 3 over 1. So graphing this one, I'm going to find 2 on the y-axis, which is here, so that's our y-intercept. Then I'm going to go down 3 and across 1. So we'll go 1, 2, 3 here, and then we'll go across 1, so right here. So we've got our 2 points. Now I'm going to draw my line. Bingo. So what we can see is it's a little bit hard from this hand drawing. If you use a ruler yourself, it will look much better. So what I'm going to do is I'm going to jump over to Desmos. We'll go to Desmos, start graphing, and I'm going to input in y equals negative 0.4x plus 1 and y equals negative 3x plus 2. And what we find is the lines intersect at this point here, so not quite as clean as I would have hoped, but this would be the solution for our x and y there. So 0.38, 0.38 or 0.83, 0.885. Where are we? So 0.8385 and 0.846. So in this case, our x and y for these equations is 0.385 and 0.846. So these would be our solutions, x and y, for these equations here. Now going down to one more example, we've got question 3, y plus 2 equals x and y plus 3x minus 2 equals 0. So notice the first problem here is neither of these equations are in slope-intercept form. So what we need to do is rearrange them. So for equation 1, we've got y equals, no, not equals, y plus 2 equals x. I'm going to rearrange that. So that's going to be y equals x minus 2. So that's our first equation. And then our second equation, we're going to have y plus 3x minus 2 equals 0. Then rearranging, it's going to be y equals negative 3x plus 2. Awesome. Now, going onwards, in green I'm going to write, there we go, in green I'm going to write that our c, or our constant, the y-intercept, so c equals -2, that m equals, notice it's 1, or 1 over 1. Now for our second equation, c is going to have a value of +2, and our m is going to have a value of -3 over 1. Great. Now graphing, going to find -2 down here. So this is 1 point. Then I'm going to go up 1 and across 1 to get my second point. Graphing this line, be as accurate as I possibly can. So that's line 1. And then let's graph our second one. So getting my orange pen, I'm going to find 2 on the axis, just here, and then I'm going to do a gradient of 1 over 1. So let's go 1 over 1. Whoops, wrong one. So I should be in the orange one. So I find the value of 2, and then it's -3 over 1. So I'm going to go down 3. 1, 2, 3, and then across 1. So just here. Then I'm going to get a line and draw a line through those 2 points. Like so. Perfect. And then coloring our line in. There we go. So what we have here is a point of intersection at this point, which looks to be the solution of, that's 1 and -1. Therefore, for this set of equation here, x and y, our x and y is equal to 1 and -1. So in summary, what we learned in this video is how we can find the solutions to a pair of equations, and we did that via graphing and finding the point of intersection. So in this lesson, going back up, we set out to identify the intersecting points of a line, and we learned that the intersecting points of the line are the solution to 2 simultaneous equations.